Now we get to talk about the pH scale. The pH scale is used to describe the acidity of solution. Cranberry juice, great with vodka, just saying, is very acidic with a pH of 2.9. So let's learn to calculate the pH of a solution from that H3O plus, and given the pH, be able to calculate the H3O plus. Okay? So applying what we just learned. So the pH of a solution is used to indicate the acidity of a solution, and it has values that usually range from 0 to 14. It's acidic when the values are less than 7, it's neutral at 7, and it's basic, and sometimes it's also called alkaline, when the values are greater than 7. Okay, so here's your pH, here's your H3O plus concentration, right? So that you can see how it relates to that formula. The pH of a solution is commonly measured using a pH meter in a laboratory, or a pH paper, which is an indicator that turns specific colors at specific pH values. And the pH of a solution is found by comparing the colors of indicator paper on a chart. So, the pH of the solution can be determined using, again, either the pH meter, which you calibrate out first using standards, pH papers, or different indicators that turn different colors depending on the corresponding different pH values. So some pHs of common substances, right? So you have your very acidic lemon juices, vinegars, soda, etc., where you have your more basic, which are going to be like drain cleaners, etc. over there. Okay, so 7's neutral. Anything below 7 is going to be acidic. Anything above 7 is going to be basic or alkaline. So identify each of the solution as either acidic, basic, or neutral. So pause me and come back. So with a pH of 1.5, that's going to be acidic. With it higher than 7, right, it's going to be basic. With the pH of 3, it's acidic. 7 is neutral. This one is going to be acidic because it's less than that standard, right? And then for this one, it is going to be basic. Okay. So how do we calculate the pHs of these various solutions? Well, we use the pH scale. And this is a logarithmic scale that corresponds to the amount of HCO3 plus of an aqueous solution. So the negative logarithmic base of 10 of the H3O plus concentration. So pH is the negative log of H3O plus. So to calculate the pH, the negative powers of 10 in the molar concentrations are converted to positive numbers. If the H3O plus is 1 times 10 to the minus 2 meters, then the pH would be the negative log of 1 times 10 to the minus 2 from here, and that would equal out to minus 2.0, negative 2.0, and so that would be 2. So then we're going to practice this to calculate the pH from the H3O plus. So, yeah, your favorite, sig figs, right? So to determine the number of significant figures in the pH value, let's consider the following. The number of decimal places in the pH value is the same as the number of sig figs in the coefficient of H3O plus. The number to the left of the decimal point in the pH value is to the power of 10, okay? So 1.0 would be 2 sig figs, and then that would be the 2 sig figs. So we have to keep those equal, as you guys remember from very first chapters, or I think it was module 2, right? So because the pH is on a logarithmic scale, if we change one pH unit, it corresponds to a 10-fold change in the amount of H3O plus. And so the pH decreases as the H3O plus increases. So a pH 2 is H3O plus of minus 2, right? The pH 3 is H3O plus equals 1.0 times 10 to the minus 3, where 4 is minus 4. Okay, so we're going to be changing, and it's a 10-fold change. So the guide to calculating the pH of a solution would be then 1. State the given. 2. Enter the H3O plus into the pH equation. 3. Press the log key and change the sign, and then adjust the number of sig figs in the right to the right decimal point. So let's try this with aspirin. Aspirin, which is acetylsalicylic acid, was the first non-steroidal anti-inflammatory drug that was used to alleviate or reduce pain and fever. If a solution of an aspirin has the H3O plus concentration of 1.7 times 10 to the minus 3 molar, what is the pH of the solution? Okay, so let's walk through this. So, step 1, let's state what was given. We were given the H3O plus concentration. We need the pH, and we know that the formula is pH is the minus log of H3O plus. Okay, so let's enter them into the pH equation. So then you're going to push these numbers on your calculator. Okay, and when you do that, then we're going to do the procedure of pressing the log key and change the sign, adjusting the number of sig figs on the right at the decimal point. So you can see that the calculator display would be this. And again, these are the steps that you pushed into your calculator, and that would be your answer. Okay, and then we're going to change the sign, adjust the number of sig figs again on the right. So your coefficient, power of 10, is this one's 1.7 is 2 sig figs. This is an exact measurement. When we calculated this out, again, this is an exact measurement, and we need it to 2 sig figs. So your answer would be 2.77. Okay? Right, so let's try this. Find the pH of a solution with H3O plus of 4 times 10 to the minus 5. Okay, so pause me and come back. Or you can walk through it with me. Either way. So step 1, we're going to state the given and needed quantities. So we were given the H3 plus O plus concentration, and we need the pH, and we know, again, the formula. So let's enter that H3O plus into the pH equation. And then these are the steps that you're going to use to push on your calculator. Okay, and then your calculator is going to end up displaying 4.3979400, combining these steps. Okay, so again, this is what you're going to push to get this answer. And then let's figure out the sig figs. So we have 2 sig figs. Again, 10 to the minus 5 is going to be exact. And so your 2 sig figs is going to end up giving you 4.40.